Hello everyone, my name is Yunus Emre Çetin. Today as a student of the engineering faculty here at Marmara University, I am proud of to present the IoT-based smart weather station and ambition display system with my teammates Enes Arda Polat, Muhammed Çelik and Furkan Taratişcan. Let's think about normal weather stations or sensor circuit we usually built in our labs. They work well, but they are completely static. They just print numbers on a screen. As a team, we wanted to something different. We asked ourselves, can we build an electronic device that doesn't just read data, but actually feels like a living friend? With this idea, we designed a smart system you see on the screen right now. It gets real-time internet data and local sensor data all wrapped in a fun moving phase. To make this idea real, we needed a strong brain for the project. We choose the ESP32 development board as our main controller because it's powerful and has a built-in Wi-Fi. Our system gathers data from two different places. First, from the internet, the ESP32 connects to Wi-Fi to get the exact time and the live weather for Istanbul using a web API application. Second, from the physical room, we added three different local sensors. We have a light sensor, measure room brightness, and a temperature sensor to calculate the exact room heat, and an ultrasonic distance sensor if someone is near. By mixing internet data with a local sensor input, we create a system that knows everything about its environment. Here we coded a pair of the moving eyes. This is not a looping video, it's a smart face, the react sensor. If the light sensor sees room is dark, the eyes slowly go to sleep. If the temperature drops, eye looks the cold, eyes shiver. If the distance sensor sees someone walking up the desk, the eyes wake up and look forward. We turned the simple circuit board into the interactive desktop friend. Of course, putting all these parts together and the controller brought big engineering problems. Our biggest problem was the code stopping, getting data from internet, reading the sensor takes time. If the processor stops to wait for the internet, our moving eyes would freeze and glitch. To solve this, stopped using simple delay codes. Instead, we used the coding method that runs text at the same time without stopping. This makes sure our animation runs smoothly while the Wi-Fi data and updates in the background. One second big problem is wiring. Both screens use the exact same data lines. We had to carefully manage the connection and give them strict hardware address like 03C for the OLED and 027 for the LCD, so the data packet wouldn't crash into each other. Also, we had a built exact 10,000 ohm resistor circuit to safely read the light and temperature sensor using the 3.3 voltage loggage of the ESP32.
What you are looking at is not just a standard sensor hub. It's an optimized, responsive illusion of an AI assistant. Let's start with the mimetic engine. The eyes on the OLED screen are not playing a pre-rendered video. They are generated in real time using complex mathematical formulas and trigonometry. By blocking the ESP32's I square C bus to a 1 MHz turbo speed, we achieved a completely glitch-free 60 frames per second animated loop. The system constantly calculates random combinations of eye light positions, blink rates, and glance directions to simulate a living entity's shifting moods. Secondly, we have environmental evidence. That project constantly filters analog data from the LDR and ENC sensors while signing with the Open Weather API Wi-Fi. But it doesn't just display those numbers. It evaluates the time of day, the indoor temperature, and the weather to generate contextual, the dynamic messages on the LCD. If the room gets too hot or if I am working late into the night, the system reacts uniquely to the situation. Finally, our smart energy management using the ultrasonic sensor. The system tracks micro movements within a 1.5 meter radius. If it detects absolute stillness for 30 minutes during the day or 15 minutes at night, it cuts power to the display and enters a deep sleep mode. However, the moment I return to my desk, it wakes up within a single second, runs the utilizations protocol, and welcomes me back. In short, the project demonstrates how we can push the progressing limits of a pro controller to an autonomous, interactive, and highly optimized desktop assistant.
Thank you very much for watching. If you have any question about circuit wiring, the coding design and element works, my team and wouldn't happy to answer them.